Yes.
Presentation is visible, but electric and hybrid vehicle and all those things, why has it become very faint? Can you make it darker?
So yes, I changed that colors.
But it has become very faint. You can keep it black, I don't mind.
Okay, sir.
Anyways, you can while you are submitting, you keep that. Whatever topic, that topic should be highlighted very much. So other things, it's okay. Because I asked you people to keep the same format for the title slide, so try to adhere to that. So this is a new topic, PHEV. So this is from the book of Masroor. Okay, so a
Yes.
new book is we are doing it from the book of Masroor, which is a very special book for EHV and all. And we have just now started discussion on PHEV, which is not there in our syllabus, but which is very much relevant with the present EHV technology. So Siddhivinayak and Vinayak, they have explained or they have laid the foundation for PHEV. Now Asit and Karthik, they will be talking about fuel economy and power management in PHEV. So
Okay, sir. This is the outline of presentation. So this is the first fuel economy and the introduction of that will be explained by me, and the next three topics will be explained by Karthik, and the power management of electric vehicle and the next few topics will be explained by me. So fuel economy. Fuel economy is nothing but the union liters per 100 kilometer mile or miles per gallon. So and it is a fuel economy of a petrol vehicle, and to convert it to the electric vehicle, it is defined as fuel economy of electrical vehicle is the union kilowatt hour per 100 kilometer. And this is the equation for the I mean gas equivalent of electrical vehicle equation. So for 1 watt hour, how much does for 1 watt hour, what is the gas equivalent of that electrical vehicle? So this is the equation, and there is an example below that if a passenger car consumes 240 watt hour per mile, so its gas equivalent is equal to 140 miles. That is 240 watt hour divided 240 watt hour, and you have to 33,700 divided by 240 watt hours. You will get 140 miles per gallon. So this is the and 240 watt hour 240 watt hours is generally a top model electric car which produces that kind of efficiency, generally a lucid pure air or model S. So there are generally two approaches for fuel economy. One is checking the efficiency, and second one is the checking the utility factor. So this part would be explained by my colleague Karthik.
Good afternoon, sir. So, as
good
Ashit
afternoon.
showed, that one was also known as has tank to wheel efficiency. So that means that is defined as the ratio between energy output from the wheel to the energy output of the fuel in the tank. So,
Correct.
wheel to well to wheel efficiency here. Well is the fuel pump, means the definition of this remains the same, but only at the last. You can say it as the ratio between the energy output from the uh, uh, wheel to the energy content of the fuel pump. The difference between that and this is in this in that we don't get the losses. The loss We can see the losses in this. So above equation doesn't contain the losses. The loss which we speak in this are about the refining and distribution electric. So for electric vehicle, we have to include generation, electric distribution, and charge efficiency. The charge efficiency is the ratio of the electric charge capacity during discharging to the during charging. So mm, for gasoline, the efficiency is 83 percentage, which reflects lumped efficiency. Lumped efficiency is like combined efficiency from the refining and distribution of gasoline. For electric generation, this efficiency is 30.3 percentage, which reflects a lumped efficiency that includes electric generation.
Karthik, Karthik,
Yes.
where are these figures actually? This 87%, 33%. It is not visible anywhere
Uh,
in the slide.
Sir, in the pie graph, I'm going to explain about that one.
So in pie graph, whatever the colors are there, there you have to give these figures. That will
Yes, sir.
make the presentation a lot better.
The effective power that shows the 30.3%, sir, which is
Correct.
the
So in that green also you had to mention that. So it roughly we can understand that because the dark red, the pink and the green, they are almost one third of the whole pie. But if you
uh,
mention that whenever you are submitting it before by in Google Classroom, before that you just mention the exact figures there.
okay, sir.
So whenever you are presenting, it should be you are trying to, so like as a chef, he cooks the best food and serves it to the customer. So whenever you are presenting, you have to keep in mind that you have to serve the best presentation, which is most easily understandable and with full of details. So don't
Yes,
keep
sir.
the audience ambiguous. Okay, so supply as best as possible. So just write all the
Yes,
values there. Asit, you please note, and then you can uh, go on forward. ठीक है? चलो,
Yes, sir.
let's begin.
yes, sir. So the effective power over here is 30.3 percentage, and the rest all are the losses which we get. So the frictional loss is a loss of the pressure or heat that occurs in the pipe flow due to viscosity near the surface. Uh, and About the electric distribution and the generation, here the electric generation is 30.2 percentage, and the electric distribution electricity is at 92.4 percentage. Also, the charge efficiency of the battery needs to be affected. So, fuel economy of EV wheel. Oh, no, that one only. That slide. Same slide.
Previous slide, please. Yeah, stay.
Uh, so in this case, we can only the same equation remains with an multiplication of the efficiency of the losses. So in this, we can see the F FEEV wheel is equal to the fuel economy of the electric wheel with losses, and the electricity is the electric general efficiency. Next slide.
How much is the value of ETA electricity generally?
30.3 percentage.
ETA electricity 30.3%. That means ETA is 0.3 something. Okay, proceed.
Uh, so PHEV fuel economy. Here we consider two PHEVs for fuel economies: serial PHEV and parallel PHEV, which is all for the serial PHEV, which is also known as extended range electric
Correct.
vehicle or all electric cable. Only electric motors turns the wheel. Gasoline engine only generates electricity.
Acha.
Uh, the it is used to indicate the electric charges in miles or kilometers and associated energy consumed during that range in a kilowatt hour per mile, and potential gas equivalent mpgs. And the next is parallel phevs. Both electric motor and gasoline engines are connected to the wheel. So the diagrams which we can see are these are in the ads. So the fuel economic labeled for blended is the second one. Here uh, in this it's both for CD and CS mode, but in the second one, the series one, it is only for CS mode and for the range, which is used for the ranges.
Correct.
So next slide. Utility factor. It is generally defined as the CD range of PHEVs to the total distance driven in daily communication or daily people. Like, so
Commutation. It is called commutation. Commutation means traveling. Commuting from home to office, office to home. Okay.
yeah.
Commutation.
How? So fuel economy of gas equivalent is equals to 1 divided by that for 1 divided by UF plus 1
Yeah,
minus
formula
UF.
is visible.
Uh,
Formula is visible. Don't explain.
uh,
Huh? Just explain the factors.
so the UF in this is a utility factor, and FECD is a fuel economic in a CD mode. CD is a charge depletion, and the next is CS mode, charge sustaining. Uh, so in this
Have you
in the
understood
graph,
the charge depletion and charge sustaining mode? Vinayak and Siddhivinayak, they have explained it in the previous
yes
presentation
sir,
also.
uh,
So charge
yes sir,
depletion and charge sustaining, both these modes you have understood, right?
yes sir.
Okay, fine. Proceed.
So the VTM in the diagram we can say that is known as the vehicle miles traveled, a vehicle per mile traveled. So here we can see that if we consider CD ranges of 20 miles, then the utility factor will be of 40 percentage.
Correct. From the graph, it is visible. You just bring your cursor on that same point. So at 20, you are coming to 40. Correct. So this is
Yes,
the point. At 20 miles, you are coming to around 40% utility factor.
yes, sir.
What next?
So from next slide, Ashit will explain.
Okay.
Uh, the next part is the power management of the PHEVs. This is an important topic because it mainly decides the range of the electric vehicle. So while these there are some operating conditions in the power management. So first one is the battery. There is a casing. There is a photo of a casing, and the gold covered foil represent the battery covering. So this is the battery. And CS mode, there are two modes while operating this. So there are CS and CD mode. So CD mode is nothing but you need to if you compare it to the mobile phone, so it is at full charge. Our mobile will be giving it a better performance and efficiency. When it reaches a certain limit, that is about 15%, and so the efficiency of the mobile will decrease because it will try to save the battery. So in CD, our aim in power management is to make use of the battery in efficiently in CD mode itself. So while power management, again there are two cases. So the first case is if the trip is less than the drive range. So there is no problem if the trip is less than the drive range. It would perform as it was programmed. So, and the next case is if the trip is larger than the drive range, then we have to do some algorithms to save that to for the passenger to reach his destination. So if the trip is larger than the drive range, the operating until the battery is depleted. So the next case is operating at blending mode. So at this mode, the electric motor turns on when the high power is required, like at a greater grade angle or grade angle of the road, or in rough surfaces like these conditions. And another one is operating on blending mode plus some discharge policies. Discharge policies are nothing but to use the battery effectively according to the computer algorithms, such that it will be constantly varying between the modes. So this example is a beautiful example of a Model S. So as you can see here, this is a dashboard's UI. So as you can see, this Model S has run out of battery. So another important point is it is showing it as zero battery, but there will be always a reserved battery which will be used for hybrid applications. So there is an indication that battery power very low, heating and AC are reduced. So another topic comes into mind, that why there is a requirement of heating in an electric vehicle. So we need to heat the battery. So we need to heat the battery because at low temperature the battery's performance decreases, because heating adversely affects the internal resistance. So that is inversely proportional, and then the performance of the battery decreases, and AC is also received. So AC means doesn't mean only cool air. As you can see, there is 11 degrees Celsius outside. So the passenger may have turned on the heater from the air conditioner. And this is a graph which explains the battery at high and low temperatures. At low temperatures, the capacity and voltage decreases. So Q is equal to CV. So lower are the values, lower is the performance. So and at higher temperatures what happens is the battery's life decreases. So we have to be in between this graph for the longevity of the battery. So these are the operating conditions of the and calculations. So this is nothing but the second condition operating at the blending of what are the calculations required for that. So this is these are the blocks, the battery to motor, and there are several parameters missing, but it is just idealized for better understanding. So there for engine and motor, there is a mechanical coupling, transmission and vehicles. These are the equations. The total power is equal to the power of the motor plus power of the engine, and battery power is equal to power of the motor plus the losses which occur in the battery and motor. So this is the energy of the battery, and this is the fuel economy which was used. And the next slide is these are the power distribution graphs. So this graph is also very important because this power demand versus occurrence number graph is plotted through drive cycles. So drive cycles are nothing but there are a series of data points. We usually use drive cycles in simulating the uh, expected range of that vehicle, and these are produced by different countries and organizations. Some European countries produce it by theoretically, and some produce it through from surveys and all those things. And this drive cycle explains that from when for example if you're driving a electric or if you're driving a normal scooter, so you'd go from 0 to 60 on a highway, and then if you hit a red light you again fall to 0, and then again you go to 120 if there is a national highway. So these are the drive cycles which we provide to MATLAB's model electric models to simulate those conditions. So and this graph, normalized power demand graph, is the graph that is normal that the this power demand versus occurrence graph is normalized to this one. So this is the area highlighted under the graph is the power demand for the today's vehicles. So these are the references which we have preferred. So for the image of the Tesla, we preferred this website, and for CD and CS mode information, we preferred ResearchGate, and for Get Green Tech, for more information about the battery temperature and all those things, we preferred this website, and for the data on the price chart, we preferred this AAA.com website. Thank you.
Go to the previous slide, zoom. Previous to that, block diagram one. Yeah, between transmission and vehicle, just make the line dark.
Okay, sir.
So such things, a little bit formatting issues are there. Technically extensive thing you have made, and titles if you are putting centrally, it will be looking better.
Okay, sir.
And so these are some of the corrections, formatting error that if you can complete, it'll be good.
Okay, sir.
So now you can sign off from this presentation. So be in the meet. So it's a good presentation given by Ashit and Kartik. Uh, with some more time, I think you could have given a lot better presentation, but within this time, whatever you have shown, it is commendable.
Okay, sir.
So now group number C3, I am asking Shreyas and Saurabh to please launch their slide and present.